Today we're going to review topic 4-4, operating with numbers expressed in scientific notation. First, we need to know a couple of things. Adding and subtracting numbers in scientific notation means they must have the same power of 10. Also, we add or subtract the first factors of the numbers, and we keep the same power of 10. On your sheet, there is an example of an adding problem and an example of a subtracting problem. Please follow along with the screen. The adding: 6 times 10 to the fourth plus 2 times 10 to the fourth. Same power of 10. The next is we add the first factors of the numbers. 6 is the first factor, and 2 is the first factor of the second number. So in the first set of parentheses, we have a 6 plus a 2, and we have the same base, same power of 10, 10 to the fourth period. When we combine the 6 and the 2, we get 8 times 10 to the fourth power. Subtraction: 9 times 10 to the negative 2 power minus 3 times 10 to the negative 2 power. So the negative 2 power on the 10 is going to remain. We're going to take 9 minus 3 and get 6. So we took the first factor from each of the numbers, the 9 and the 3, subtracted, got 6. And we keep the same power of 10, 10 to the negative 2 power. On your sheet, please make sure you filled in those numbers. Please look to the right and see the algebra rules. In the middle of your handout, there's a question that asks, what happens if, after you've added or subtracted two numbers, and they were both in scientific notation, if the answer is no longer in scientific notation, what do we do? There is an example of a problem: 2.5, 2 5/10 times 10 to the negative 9th minus 2 1/10 times 10 to the negative 9th. On your sheet, I've given some blank lines I would like for you to solve using the steps we just performed. Take the first factor from each number and combine them, and then we stay with the same base, which is 10 to the negative 9 power. Okay, hopefully you have on your paper what is up on your screen, which is 0.44 times 10 to the negative 9 power. We had two numbers that were in scientific notation. We subtracted, and we ended up with a number that is not in scientific notation. So we take the 4/10 times 10 to the negative 9 power, and we move the decimal over one place to the right, which means we're going to have to also adjust our power from a negative 9 to a negative 10. It's no longer 4/10. We've moved the decimal to the right. It is now 4 times 10 to the negative 10 power. Right below that question or that problem is the focus question. And next to it, it says page 3, which is where we are now. Focus question is, you previously learned how to multiply and divide expressions with exponents. That's what we just finished doing in topic 3. How can you apply what you know to operations with numbers in scientific notation? As we get into the multiplying and dividing of scientific notation, you're going to see there's an incredible similarity. So you will instantaneously know how to do these. Immediately following your focus question is a got it question, and it simply says to simplify. 5 9/10 times 10 to the 5th power plus 4 3/10 times 10 to the 5th power minus 2 2/10 times 10 to the 5th power. I'd like you to turn off the machine for a minute. I'd like you to take those three scientific notation numbers. You have two that are being added together, and the third one is subtracted. And when you come back, we'll see if you have the right answer. If you combined the 5 and 9/10 with the 4 and 3/10 and got 10 and 2/10, then you subtracted 2 and 2/10 from 10 and 2/10, you should have ended up with 8, or 8.0, times 10 to the 5th power. Next, we have multiplication of numbers in scientific notation. Step number 1 says use the commutative and the associative properties to group the first factors and to group the powers of 10 together. Then find both products. Since the powers are both base 10, you can add the exponents, which you already know how to do because that's what we did with topic 3. So the problem is 2 times 10 to the negative 5th, in parentheses, times 3 times 10 to the 11th power, in parentheses. So we use the commutative and the associative properties. We group the first factors, which is 2 and then 3. So those two are together. And then we have two different exponents. We have 10 to the negative 5th and 10 to the 11th. And you learned in topic 3 that when you multiply, we add the exponents. So we have the coefficients. We have the 2 and the 3, which are being multiplied to give us the 6. We have 10 to the negative 5th being combined with 10 to the positive 11th. Together, we end up with 10 to the positive 6th value. So the answer is 6 times 10 to the 6th power. Similar to the problem that we had regarding addition, we now have that same type of problem regarding multiplication. What happens if, after you multiply two numbers that were in scientific notation together, then the answer you get is no longer in scientific notation? So the problem is 6 times 10 to the 4th power times 4 times 10 to the negative 7th. Both of those are in scientific notation. We take the first factors, the 6 and the 4, we combine them. We combine the two powers of 10, 10 to the 4th and 10 to the negative 7th. So we carry down the math and we end up with 24 times 10 to the negative 3rd power. This number is not in scientific notation because the number 24 is not less than 10. And remember, scientific notation must be greater than or equal to 1, but less than 10, and 24 does not fit in that range. So we need to make that into scientific notation by moving the decimal one place to the left. So it's no longer 24, it is 2.4. Our exponent is no longer negative 3, it's negative 2. And sorry, I forgot to mention it, but that problem is at the very top of the reverse side of your guided notes. We have another multiplication problem. It says it's on page 7. In parentheses, 2 times 10 to the negative 5th power times, in parentheses, 3 times 10 to the 11th power. If you can combine the first terms and then combine the powers and come back, we'll see if you got the problem correct. Hopefully when you combine the first factors, you got 6, and when you combine the exponents, you got a positive 6 as well. So the answer to that problem is 6 times 10 to the 6th power. The next example, next we have a word problem. It's on page 8, or this is page 8. A carpet can contain millions of dust mites. Suppose the length of a dust mite is 2 5/10 times 10 to the negative 4th power, and that's meters. If a carpet has 1 million dust mites and they all crawled away in a single file, how long would that single file line be? So we need to set up the equation, starting with 1 million dust mites. Put into scientific notation would be 1 times 10 to the 6th power. We have the length of one dust mite as 2 5/10 times 10 to the negative 4 power. So when we set up that multiplication, this is what we have. We're going to use the associative property, and then we're going to combine the first factors, get 2.5, combine the exponents, which are -4 and +6, and come out with a +2. So the answer is 2 5/10 times 10 to the second power. That's how long it will be. 10 to the second power is 100. So 2 5/10 times 100 is 250. So the line of dust mites would be 250 meters long. Okay, here we are on page 9. We have a question, word problem regarding bacteria. About 1 times 10 to the 8th power bacteria live in a human body. If there are 2,000 spectators at a football game, how many bacteria are living in the spectators? Let's see if you can set that up. I'll come back and we'll see how you did. Oops. Well, if you went to set it up, you saw that there was only one number that had the power of 10. So we took 2,000 times 1, and we ended up with 2,000 times 10 to the 8th power. And we all know that that is not in scientific notation. To make the number 2,000 range between 1 and 10, we would have to move the decimal over 3 positions to the left so that the decimal is between the 2 and the first 0. When we do that, we have to take the existing exponent, which is 8, increase it by the number of movements that we're making in decimal places, which is 3. So the exponent goes from 8 to 11, and our coefficient goes from 2,000 to 2. So the answer is 2 times 10 to the 11th power. Okay, we have 2 more problems. This is a division problem. To divide numbers in scientific notation, we write the expression as a product of quotients. Then we find both quotients. Since the powers are both bases of 10, we can subtract the exponents. This is very similar to what we did in topic 3. So we have 10 to the 4th power being divided by 10 to the 9th power. So hopefully you remember, since that was just last week. All right, so when we subtract, we have 7 over 2, which reduces to 3/5. When we subtract 10 to the 9th power from 10 to the 4th power, we end up with 10 to the -5th power. 3.5 is in scientific notation. So the answer is 3 5/10 times 10 to the -5th power. We have one last question, which deals with beetles. If beetles of the size shown stood end to end, kind of like the dust mites, to make a line 1 in 2500ths times 10 to the 2nd power meters long, how many beetles would there be? They show you one beetle. They show you the size of it, 3 1/10 times 10 to the -3 power. Take 30 seconds, set this up, and see if you can come up with how many beetles would have to be there. Okay, hopefully you started with 1 in 2500ths times 10 to the 2nd power as your numerator, divided by 3 1/10 times 10 to the -3 power. When we take 1 in 2500ths and divide it by 3 1/10, we get 0.403, or 403 thousandths. When we take 10 to the 2nd power and divide it by 10 to the -3rd power, we end up with 10 to the 5th power. So what we're looking at is 403 thousandths times 10 to the fifth power. Well, 403 thousandths is not in scientific notation. So we just need to move the decimal place over 1 so that our coefficient will be 4 300ths. So 4.03, 4 300ths, times 10 to the fourth power. We no longer can have it to the fifth because we've moved our decimal place over 1. So let me move this. The answer is, there would be about 4 times 10 to the fourth, or 40,000 beetles in that line. On the last page, or in the last section, I've listed some of the problems from your student companion book. What I would like for you to do, that is not listed on the sheet that I've given you for guided notes, but I would like you to take that out of your student companion book and answer those 5 questions. So when you turn this in on Monday, please have your guided notes completed as well as these 5 questions from your student companion book. All right, have a great weekend.